Hey everyone, welcome back to making a Pokemon save editor in C. This is part 15, I want to say, part 15. So I had a recording from last time where I was going through how to load Pokemon data and decrypt it because there's some encryption that happens. Basically, for a long time, something was kind of off, and we discovered what it was. It was that this struct is incorrect. So this misc flags here is actually just an unsigned 8-bit integer rather than a structure of multiple unsigned 8 bits. So having fixed that, Pokemon is now the correct size and the data decrypts correctly as well. So that works really well. What we want to do in this episode, there's a function here for Pokemon data checksum, and ours is still incorrect, even though we've implemented a function that should give it to us. So I have a function here called checksum calculate, but this is actually this should be save checksum calculate. And then we have a separate function for our Pokemon. So yes, Pokemon calculate inner checksum. And probably this name as well can just be renamed to Pokemon calculate checksum. I think that's a good name. So something here is wrong. So what we want to look at is the structure of a Pokemon, which I think we can see in team and items. So after trainer info, we have team and items. And then let's look at the Gen 3 Pokemon data structure. So there's a section here called checksum. So this is the checksum for the 48-byte section of this structure. It is computed by adding all of the unencrypted values of that section one word at a time. If the computed checksum and the stored checksum do not match, the Pokemon is interpreted as a bad egg. So I had a function before which I completely removed, I believe, for reversing bytes. And that was because it turns out that even though... Okay. Oh, it's actually there in the header file still, so we probably don't need it in the header file. So even though we had a lot of help from this particular text file here, this makes reference to lots of things being in reverse in the save data, but it actually looks as though we've loaded it properly. So, or rather that we don't need to reverse any data, so that's good. So I wanted to check that I wasn't accidentally reversing bytes where I didn't intend for them to be reversed. But I don't think I am. So let's go in and actually just run our function in the debug mode up until this point. So what's not correct is if we open our Pokemon, here is its checksum. So that's 8A54. Or 548A, whichever way around you want to see it. And then the one that we've calculated, based on the decrypted data, is 4D4D. So that clearly isn't right. Even though we know from the last episode that our decrypted data is now correct, because we got things like this is Squirtle's species and this is its XP or something like that. So, oh sorry, that's its held item. So something is not right, presumably in the calculate checksum function. So I don't see why it would be wrong. The checksum is a 16-bit. Yes, it is a 16-bit integer. So what are we doing? So we're reading one word at a time. One word, which I believe in this context is 32-bit. Does it actually say word? Yeah, 32-bit word. And add it to the variable. So we have our 16-bit initialized to 0, and then we add word each time. I mean, to be honest, we don't need this, like, word function here. And in fact, this can probably just become, like, pointer. So pointer to a 32-bit word. And then we can just do calc, add the dereferenced pointer, which should increment the value. I also wonder if we can do something like that. Let me just check that syntax is correct. Because rather than incrementing the pointer, I'd rather do that. So what is... Oh, do we get rid of X when we leave that scope? Yeah, okay. Okay, in that case, we want to be there. So... Okay, so X is D007. Yeah, D0007. Yeah. Okay. So actually that is right. And then we just go until we return calc. So this pointer is looking at that. Then it's looking at that. So it is increasing in size. Also, this is old code now. So let's do like some print debugging here actually, and just say the current value actually that should be then our word value then I guess our position, which should be pointer. And yep, that is right. So let's actually just go up until this point and see what we got here. That didn't print anything? Really? Why did that happen then? We need to rebuild that? Okay. So we had various iterations. So we still have the same result, 4D, 4D. So yeah, it's 4D, 4C, and then we add one word onto that. Now, I wonder if, you know, we've only got two bytes here, but we're literally adding 32-bit words to that each time. So, is it actually a 32-bit? Let me just see if we can get away with a 32-bit, or what a 32-bit integer would look like instead. So this instead, yeah, looks a lot more like sensible. 3D 08 4D 4D, at least that is actually using all of the space in there now. But then if we go back to our main stack, what does Squirtle's checksum add to? It's still a value that I don't really recognize. 8A54, which is not inside calc at all. So that's a bit strange. Let's consult the check, not the check file, the text file. So byte 30 through 31 of a Pokemon is the apparently reversed checksum. Checksum is the adding of unencrypted words, all the ABCD structure. So I assume, yeah, just adding this one word at a time. It shouldn't matter that the order Squirtle's data is in doesn't correspond to what we've loaded into our data structure, which is fixed to be the G section first, then A, then M, then E, because we're just adding. So, although actually, if this is a 16-bit, maybe it does matter. Does it matter? No, I don't think it should matter, because it would be the same result anyway. It should be the same result anyway. We can probably prove that by changing the fixed data type here to actually fit what Squirtle's is, which should be EAMG. Yeah, EAMG. So if I go to wherever I was before, so E can go here, A there, M there. Let's try that instead, and let's revert back to a 16-bit integer. So yeah, we still have 4D, 4D. I do wonder as well, what is this data that's after? Is this pointer actually reading the right stuff? It should be. I guess we can test that. On every iteration is pointer reading the right data? Maybe I did that a minute ago, but let's see. So X here. Huh. Really? 00002. That doesn't look right to me. Oh, or it is right. Oh yeah, I guess so. Okay, fine. Oh, but is this not reversed? If this is 0012312, is that right? I'm not sure if it is. Maybe we do need that bytes reverse function back. And I was too keen in getting rid of it, but I'm sure I didn't see any uses for it whatsoever. Oh, and I don't have version control yet. So I have to write this function again. Fuck. Okay. All right, let's see. I think it was void bytes reverse. And then we need some kind of unsigned car pointer, which we'll call source. And then we need some kind of unsigned len, which is the number of bytes to be reversed. So this reverses the byte order of SRC by swapping len bytes. I don't know. So we then do for Yep. So in this for loop, we want to have a some kind of unsigned character, which I guess can be source I. Then we want to say that yes. And yeah, I guess briefly that could be const because we're redeclaring it each time. Then that's it, actually, because it reverses it in place. So if we then add this to our header file, let's see if we can use that here. So the words that we're pointing to almost look like they might not be right. So what we could do is bytes reverse x, size of x, and that needs to be cast to unsigned character pointer. And then we add x to calc instead. Actually, it's not const. Okay. Cool. So... Oh, we have an exception. What did we do? This is source I... Oh, what happened there? Oh, it fucked up. Probably on loop 1? Oh. It is probably because I'm not sending... Yeah, this is a pointer, so that needs to be the address of X. There we go. That should work now. Yes. So what do we get with calc? 73C, which is still not right. Because it is actually 8A54. Or 548A. Byte 30 through 31 is that. So actually in Squirtle's data, it says there's unused bytes here, but then this says the ABCD structure is byte 32 through 79. In fact, what actually is a size of Pokemon? It should be 80, yeah. So the text file is saying literally straight after byte 31, you have data. But this is saying in Bulbapedia, there is a unknown... There are 2 unknown bytes before the data begins. So... Possibly simply padding, not used and usually set to 0 or -1, depending on the data type. And yeah, this is... Okay, that's just all the items. So there's not much more help here. It does say the checksum's in reverse, but it says everything is in reverse, but we haven't reversed any bytes. Well, we haven't needed to, so... Okay, I guess we don't need to reverse the bytes here then. So let's leave that blank. So we can rule that out as being the problem. It's not that we are reversing bytes when we don't need to. So that takes us back to 4D, 4D. And then this did traverse the whole structure. And it found data and added that to our calculation. Oh, hang on, sorry. Word is calc. So we can see this going up each time. We have 022, FB4D, FC4D, then 4D, 4D. The actual is 8A54, so significantly larger than what we have here. Now that is interesting. And it says here the checksum is computed by adding all of the unencrypted values of that section one word at a time. Well, given we haven't modified anything yet, they should be equal. So that is very Interesting. Okay, let's see if we can figure this out. Because this is the final hurdle that is stopping us from being able to modify Pokemon data. So as soon as we crack this code, we are flying. Probably what I will do is go back to... Oh, it can't show us type source? Okay. Go back to here and just put this back. So I'll put it in game order. And let's make this look nicer as well. So that we know doesn't make a difference as well, so that's all fine. So I don't think we need this. I wonder what happens if we were to try the same thing but on the encrypted data. This is just kind of theory crafting here, but it would be interesting to see. Oh, does it need to be Pokemon data type? I think it does, right? So I probably need to cast this to... Okay. And that should still be valid because they're the same size, so... let's go back here. So that's CEC7, but that's still not what I'm looking for. 35412. No. No. Not correct. So it's not adding the encrypted bytes either. I mean, where it says one word at a time, do we want to be adding them 16 bits at a time? That could be the trick. So that needs to be size of uint 16 if we're going to do that. Let's give that a try. Oh. Is that 8A54? That is the same. That is the same. Okay, all right, fine. So we do them as yeah, okay, 16-bit words at a time, not 32. Okay. Now that is cool. So I think we can test everything that we've put together now by making a very simple change to some of Squirtle's protected data. So I think we can do something very simple, like if we view the data here, we can set the Pokerus flag. So if we look at that, it's stored in a single byte with upper and lower halves representing distinct values. So any value from 0 to 15 is valid for the strain. 0 means it doesn't have Pokerus at all. The number of days can be any value from 0 to 4. If any bit is set in the strain and the number of days is at 0. The Pokemon has been cured of Pokerus, indicated by a small black dot on its... Okay, alright. So that means... I mean, we could also just give it more XP or, like, hack in a move. That could also work. We could hack in a move. Should we give it, like, Surf? Why not, right? Can it learn Surf? Is there any protection there against that? We can find out, I guess. So there's a lot of data here from the text file that we could use. Okay. What is it? Let's pick one. Let's pick one. What do we want to do? A move, or because move would involve importing all of these, which I guess we could do. Yeah, let's do that. Let's hack in a move rather than do Pokerus, because I'm not 100% with modifying specific bits here. So let's take these moves. And, I mean, the issue is I don't really know how much PP these have by default. I guess that remains to be seen. So what I'll do probably is create a header file for these, and we will add them to targets. We'll call these moves. We'll call this moves. And we'll not paste all of that data in there, but we want to write a script or something that can generate this for us. I think it probably makes sense to put everything in an enum. So the enum that we have here is something like this. So let's do... Yeah, let's do a Python file that can generate this for us. So let's do our raw text. Then what do we want to do with this text? I think we want to split it by lines. Then we want to... In fact, if it's an enum, we just need literally everything after the equals. Yeah. So let's make like a list for moves and say for move in txt, or let's call this line actually. So the move is if we were to split the line by the equals, we want the right hand side of that split. Then I guess we want to replace any spaces probably with underscores. I think that makes sense. And convert it to uppercase as well. And then add a comma at the end of each one. I think also it would help if we had a some kind of a comment in there as well to say the byte. So actually, let's take that move number as well, and say but how do we do that as hex? Is that valid? I can't remember the formatting syntax here. Yes, I guess we want that. Does that work? Yes, it does. Okay. Yeah. All right, and then let's do for m in moves, print m. And that should give us our enum data, hopefully. So let's do that. Python 3 move enum. Oh, it's a string. Okay, fine. We can just cast that to an int, no problem. You didn't print. Oh, because we didn't append to moves. Okay. Or, in fact, we can just print as we go. We don't need to do this append. Yes. Okay. The only thing that would be nice is, like, the padding for this. Okay. Let's see if we can do print padding in Python. Justified in a string of length width. Okay, so what is the longest? That would be interesting to see, actually. So let's also get rid of these words. And then let's do... yeah, let's split by that equals again and only take the -1. Or in fact, let's actually just do a list. And then let's do... oh, is... okay, yes, it is key. I guess it's just len. Yeah? It's either smelling so... oh, okay, there's multiple maxes. So how many characters is smelling salt? In fact, actually, we want to append moves after we've done all that to it. Yeah, so there's all kinds, but it's however many characters this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, makes sense. So then we can do I don't know, let's do a width of 14. And then maybe that should work. Yes! That is very nice. Huh. Look at that. Okay, so enum moves is all of this. And it has issues with things. Ah, there are hyphens in here, which we don't want. Yeah, we don't want those. Okay, fine. So let's go back to this, and we want to replace any of dashes with underscores as well. So let's copy this data again, wherever I was before. Here, possibly. Let's go all the way down, paste that in. Okay, yes, it has no issues with it this time. Fab. Cool. Okay. So and that formatting looks really nice as well. So what we can do then is say that once we've decrypted the inner data, we can give Squirtle a move, and the move will be surf. So let's include moves. And then going back to where we were, let's say decrypted M. Oh no, it's not G. Which one is it? A for attacks. So we have 3 moves currently, so I want to set move 4. Should be... Oh, does it not like us doing that? So you could set fissure, but let's do surf. Oh, it might be worth actually prepending move to everything. Whatever. Let's just go with it for the moment. And then the PP for move 4 should be 15, which is Surf's default PP, I guess. Let me just double check that because I'm now doubting myself, but I'm pretty sure its normal PP is 15. So surf move. Yes, 15. Is that the case in Gen 3? I assume it is. Okay. Fine, let's go with that. So 15 there for that move. So now that we've set that data, we can then calculate the checksum again. But now we need to be able to write that data back into the Pokemon data block. And I think this is also quite simple. We just need the... we want to get the substructure order again and write back in a particular order as well. So Here we have a function which starts out the same way. What is this unsigned character pointer? That's our data block. Okay, so let's call that PDT. Oh, but then we need to encrypt that data again. So we also need to do a function that can encrypt it back. But that's fine. So let's do our switch again. And let's do EAMG. Why is it complaining? Why are you complaining? Okay. So here, we want to do pretty much this operation, but the other way round. Oh, but actually it's probably the init 12-byte section the other way round. So because what are we doing there? We're just taking 32-bit words and writing them in. So let's do copy 12-byte section. So we need some kind of destination. In fact, because we're not reversing the bytes, I actually think this init function is not needed. So what is it we're actually doing here? So we're taking word buff and we're writing, so we're taking our word and writing that into it. And yeah, and then we're doing nothing and literally just writing that to our destination. So this really is not needed. We can just do loads of memcopy calls. I think. So actually we don't need another function and we can deal with that another time. So let's do another to do there. Let's say it's not necessary because we don't need to reverse these bytes anymore. Then so here where I'm doing memcopy, we can plug that in there. So our destination is actually P. Sorry, yeah, this is just the other way around. That should be E. The address of. Yeah. Yeah, so that would be E, that will be A, that will be M, that will be G. And we need another to do here, which is for all cases. Yep, okay. That seems fine. And it's complaining about this function because it's not in my header file. So that's all good. What more? What now? What's the matter? Gonna tell me? No return statement. Yes, because it's not unsigned, it's void. And it needs to be void here as well. Okay. So that works, hopefully. Okay. So let's put some code in here for the original checksum just to like print that. So that is Squirtle checksum. The exact same, but that's just PKMN checksum. Cool. So hopefully this will work. I don't see why it wouldn't. Because I don't think we need to do it as words. Like we were doing in the init function. I have so many to-dos. Okay. Oh, what is the issue here? Conflicting types. Is one of them saying void and the other's unsigned? Void Pokemon write inner data. Can we just like build this one file? Discards qualifiers, that should be fine. What's the conflicting types? Const Pokemon P, const Pokemon data type PDT. I don't have it declared elsewhere in here. What are these anonymous structs? They're not anonymous. They have names. Whatever. Have I accidentally declared it twice? Oh, I do. Okay. Yeah, we don't want that one. Oh no, we still have an issue. PKMN write inner data. Okay. I clearly had a typo or something there. So this is probably right now. Let's check our data, which is what we should have written back. Oh, wait. Oh, we haven't even called the function. Duh. Although actually, then if we've Oh no, sorry, we've calculated the new checksum, but we've not written the data back, which is what we want to do here. So pkmn write inner data, that needs to be our address of decrypted. And wait, sorry, no. I can't even remember, my memory's shot. Can't even remember the signature of a function I was looking at like 2 seconds ago. Okay, so Pokemon is first, so that needs to be Squirtle. And then that needs to be that. Or is Squirtle already a pointer? It is. And decrypted is also already a pointer. Yes. Okay. We're getting there. So now we should have new data written in here. And that looks sensible. So this was Bubble, which was 9-1. Yep. And then 0x39 is Surf, yes. And we have, oh, hang on. If the PP comes straight after... Oh, actually, no. 0F still looks fine. Cool. Now we just need to decrypt this data back. So... we need to encrypt this data again. Pokemon data type source, Pokemon data type dest, const uint32t key. Okay, so this doesn't do it in place. Maybe I should change that now. Or is it always better to return a new? I mean, I think we can probably do it in place, but let's just do a new data for now. So, because we've already got decrypted as a completely separate piece of data here, so I actually think this function, because you encrypt the same way that you decrypt, presumably. I actually think timer on my phone's about to go off because I only wanted to do an hour on this, but we're in the zone now. So I cancelled the timer. Data. Or where did it say about the encryption? Where is that? Oh, it's actually in this article here. The key can then be used to decrypt the data by XORing it 4 bytes at a time. So to invert an XOR, you're just XORing again. So we're taking those and XORing the decryption key once again. So this is actually encrypt, decrypt inner data. That's what we want to call it. So we want to take that one more time. And our source actually this time is decrypted. And our destination, I guess, is just Squirtle's data, so we don't even need this function. Yeah, let's do the risky thing and do that. and see what we get now. So Squirtle data should be a whole bunch of, yeah, 8FCF stuff. That actually looks quite good to me. So the other thing we would need to do is calculate and rewrite our section checksum. So somewhere in this code we are yeah, getting this section by ID. So how were we doing that before? So it's this code here. Whoops. What is the problem? Checksum calculate doesn't exist. Yes, because that's save checksum calculate, or rather, I mean, it's a save section checksum calculate, but fine. That has already been defined or declared. Where's new checksum? Oh, up there for the team items section. Okay. Wait, team items? That's my... What am I doing here? Oh, okay. Yeah, actually then this code can go here. Squirtle should be coming from TI data, which is being read directly from there. Okay. So we're not initializing anything new. We shouldn't be anymore. So I think if we run this code, I'm going to call my Squirtle please, because I really hope this is going to work. It'd be so cool if it did. So something has been written back. So let's go to our GBA folder. So dump.sav is our file. So what we want to do is move dump to PokemonFR.sav. And then when we try running Fire Red, let's see. Oh no, we have a bad egg and our game froze. No. Oh well, that was worth a try. It's got a mail icon. Look at that. That's crazy. Okay. So I would have been surprised if that worked. So we maybe have something wrong here. Hello, so this is a potential part 2. I'm just going to try this, and if it works, I will go through the effort of stitching this with the previous recording in iMovie. I should just start streaming this stuff, honestly. But I've done two things. First of all, I've published this onto my GitHub. It's private at the moment, but I will at least have some kind of version control here, which will be nice for me, so I can go back and reference old code. But yeah, I was thinking, you know, why do we, like, what could possibly be the reason for why we have the bad egg? And I realized that I think it's because we've not updated Squirtle's checksum with the new value. We've calculated it, but we've not set it back. So what we actually want to do here is write this. So Squirtle's checksum becomes Pokemon checksum, and then we write the data back. So if I try this again, we have our data back, let me go into my console and do the exact same thing we did before. Then let's go and try the GBA. This is a long shot, but I was like, oh, well, the Pokemon's going to be a bad egg if the checksum doesn't compute. And then I realized we weren't even writing it. So do we still have a bad egg? Oh my gosh. We do not have a bad egg. And we have... Okay, that worked. That is awesome. I am very happy with that. Wow. We did it. Okay. How cool is that? Yeah, very pleased. Very, very pleased. We have Surf. Let's use it. In fact, let's heal this guy. So let's use this potion. Okay, we're at full health. Prepare to get surfed on. Little Rattata, or Pidgey, whoever we run into. It's a Rattata. You surf. Look at that. Wow. Okay, awesome. That's great. I'm very pleased with that. Okay, I'm gonna have to go through the effort of stitching this with the previous part in iMovie now, rendering it again and uploading it, but I think it's worthwhile. Yeah. I'm very, very happy. Okay, all right, cool. Next episode then, I guess we can probably get started on refactoring some of this stuff, cleaning things up, moving things around, just, yeah, actually making this a proper save editor. Exciting. All right. Thanks very much. I'll see you in the next one. Bye-bye.